And the recording started. So if you like, Olena, you can also start sharing your, if you have an introductional slide, but I'm pretty sure that you want to see first, everyone, and then start as far as you can go. So welcome everybody to this awesome meetup today. We have Olena here. She is a really experienced speaker, live on stages, on international stages. And today we have the honor to have her here to also listen what she is telling you about data and doing stuff with data. And I mean really the special one with stuff. So she will now start her presentation, but she also, if she has, will say you a little bit about your her housekeeping rules, if there are, and then after that we are free to go.
Yeah, so as I mentioned before, unfortunately, I have only one screen, so I'll have to hide Teams here, and I hope it's going to be fine. There's not that many rules. If you have any question, comment, you want to say something, feel free, because I'm going to share my hobby, my passion. So if you feel like you want to also engage and interact, please do this. And that's about it. So can I start?
Yeah, of course. So recording started. Everyone is now in place. Setup, scene, scenario, everything is there. So it's
Nice.
your turn.
Cool. So welcome to my session. It's called Turning Data into Generative Chaos. Honestly, this is the first time that I'm doing it in 1 hour format. So I'm very excited about it because it's also about something that I love doing. It's about my hobby. It's also about art. So it's going to be fun. I hope so. There's going to be a lot of pictures, but I will also show you some code. So please just stay with me. Once again, my name is Olena Borzenko. I am working at Xibia, Germany, Microsoft Services, and the picture on the right side of a screen that you can see is not something that I took from internet, or it's not something that is generated with AI. It's just one of my artworks. And today's session is going to be about this, how I make those and why do I make those. So just once again, there's my picture just in case. So just to make sure that you know how I look. I'm also Microsoft MVP, probably for the reason that I like to share the knowledge and whatever I learn. And also I love community. It's always fun to be surrounded by like-minded people. But about today's session, it's I always loved making art, but art was never a part of my future plans for life. So I knew that I wouldn't be able to make money with it. So as life gets busy and also as I get older, I had to get a job, I had to get a university degree and whatsoever. So I had to, I had to prioritize. So I had to choose things. But I always wanted to do more art. Like I would wake up every day and I would think I still want to do it. So at some point I saw a way how I can combine it, how I can combine my hobby with my work, with my coding skills. So I started building a tool to bring it all together and actually being able to just share it with all of you and have an excuse to share my art with you. So before getting into a tool itself, I want to say a couple of words about my inspiration. So making a step back, where it's all coming from. The picture you see on the screen, this is structure of the radium atom from original drawing from Niels Bohr from 1922 presentation. And when I saw it, I think it was 1 year ago, maybe 1.5 years ago, I saw it somewhere. I think it was scientific or whatever article. When I saw it, I found it so fascinating and beautiful for many reasons. Not only because it was symmetrical and very elegant with all the lines, but also because it had such a complexity and meaning, not like philosophical meaning, but it was the structure of an atom, and it looked so beautiful. By the way, this structure, this representation wasn't accepted, but it's still beautiful, and it's still nice to know that Niels Bohr had an idea like this. So I would be always fascinated by things like this. Also for the reason that I used to study applied physics in university. So this is my degree. I always loved math and chemistry, and I was always fascinated with all the visualizations and representations of different equations and different processes. Not because it's beautiful, but also because it had such a complex things standing behind it. So that was the first thing that I saw, and I was like, I really would like to do something like that. But I also didn't want to just draw symmetric lines and symmetric shapes. I wanted to make it interesting. So at some point, sometimes I would bump into different articles, and one of them was an article about algorithmic and parametric art. So those shapes, and there's much more on the in the article on the website. Those are, for me, they look a little bit similar to the previous picture that you saw. But what I found really cool about it, that there is actually an equation that describes, like, you can use this equation and you can create the same visualization. And I thought it's very interesting. Of course, we all know some algorithms because we all developers, and we know that it can be beautiful. But I also thought it can be very interesting, like pet project, but also for my hobby to try something for myself, because I always like doing art. I'm not capable of creating a portrait or something really complicated because I never put enough hours into this. But this, I thought could be something that I could do. The formulas that you see on the screen, they called parametric formulas, and this is a little spoiler. They called parametric because they not only depend on the algorithm itself, but they also vary from the algorithm. So what you see here is the same formula basically on both sides, but it's the same formula for like kind of torus knot-like shape, but it has different numbers, different parameters, a little bit different calculations, but the principle is the same. And you can get beautiful visualizations like this. So that was something I was fascinated with. I saw it. I thought maybe one day I will try to do something like that. And then there was last summer when I went home to Ukraine to visit my family. Luckily, I have in Ukraine a lot of creative and artistic people, and I got a chance to work with something called CNC. So CNC is a computer and numerical control, or CNC machining is the automated control of machine tools by a computer. This is definition from Wikipedia, but if I would try to explain it with my words, I'm sure that many of you know what is a 3D printer is, and if not, there's also automated wood carving tool or engraving tool or laser cutter. All of them work in a very similar way. They automate a certain tool, and it can be either a rotor or a laser or a pen even. And they automate it, and the computer sends the instructions of how and where it should move and how it should move. So basically, the movements on Z and Y axis, and if needed also, X and Y axis, and if needed also Z-axis. So this is the base principle I have of how CNC machine works. And if you put, like, you can use CNC machine for wood carving or engraving because it has a motor. You can basically put anything in there, but you can also put a pen in there, and then it becomes a plotter machine. And here is the example of my first artworks that I've ever did with a CNC machine. So from the left side, you see my very first art piece. It's quite big actually. It's like I think 1 meter 10 centimeters, like per 1 meter, something like this. I had to learn a lot of new things. I had to learn how to assemble a wooden frame, how to put a canvas on top of it, how to use acrylic paint and make a brush strokes. And then I had a sketch. I didn't create the sketch by myself, so my friend gave it to me. So this shape that you see was like white lines. So he gave it to me and he said, like, you can use it for your artwork. And we used the plotter machine, well, this CNC machine, to actually finish it. I was so excited about result because I thought that all doors are open. There's so many possibilities. Like I can create as many things and as so different. It's all depends on my fantasy and my imagination. So I tried making more of those. And from the right side, you see probably the next one that I did. I'm not sure. I tried using a simple torus, and not torus node, but just simple torus, which is basically a donut shape. And I tried to break it a little bit in segments. And I have to admit that I was struggling a lot. I don't remember when last time I struggled that much learning anything, because to do that kind of things, I had to learn a little bit of 3D Smugs, and this is not my thing. I'm a software developer. I'm a very technical person. I love math equations and physics and everything around it, but not 3D modeling. So it was way too complicated for me. I think I spent a whole day trying to pull those segments out of shape, playing around with it, and just like making sure that it feels right. So the idea was just to bring some movement to a canvas. And I also wanted to experiment a little bit with brush strokes. It was my every artwork that I did was kind of an experiment. This one is also, if you put a UV light on it, it will also glow in the dark. So it was also fun to play with it. But then there was a changing moment. And those two art pieces, that was my changing moment for a couple of reasons. First one, this called diptych, which means that two separate canvases, but they are connected and they have the same artwork. And that's, well, not the same, but it's like one artwork that is split into two canvases. The thing is, when I had this idea, I wanted to create two pieces that are interconnected. When I had this idea, I had much more complex, like not complex, but completely different from what you see on the screen. Let's say it like this. My idea was completely different. I also wanted them to be interconnected. I also wanted to have broken segments, but it was way over and beyond my skills in 3D modeling. After a couple of days and way too many hours of trying and failing, I had to make a step back, not like give up on my idea, but estimate realistically my own skills. So I realized that I have to, yep, I realized that I have to take a something simpler. So I have to take maybe like a base shape in 3D Max, and I have to work with it. I still spend way too much time in breaking those segments and arranging the artwork in the way that you see it now. And that was it. That was the point when I thought that I don't want to work with 3D Max anymore at all. It was taking way too much time from me. It was way too stressful. Sometimes I was getting frustrated because I didn't have enough skills to actually bring my idea to life. And as more time you spend on the same idea, it starts to fade with time. So after a couple of days, I wasn't even being able to remember what was the initial idea. So when I finished this artwork, so I had to make it simpler. I had to struggle a little bit to the point that I was done with 3D Max, 3D Smugs, at least was experimenting. But also, I made those brush strokes, and I really liked it. I really liked the combination of brush strokes and the wireframe. So you probably see my mouse, right? So this part and this part, when you see it in real life, it looks so cool and interesting. It's like a snake skin. When I saw it, I had a thought that maybe I should try making brush strokes with wireframe only, and not making like overcomplicating the whole sketch. So that was the time. By the way, those two shapes that you see on the screen, they are torus nodes. But when I used them for the first time, I didn't even know, like, I didn't put too much thought in it. I was just, yeah, this looks good. I will take it because I wanted something that is connected like a chain. So when I realized that I'm not going to spend any more time in, like in improving my 3D modeling skills, and I have to take something, I have to go with base and primitive shapes, I went to 3ds Max Gallery and I checked what they have in there. So there is a base shape, and I said it many, many times, called Torus node. You can use it. So I already used it before, but I didn't know that it is so flexible and it can actually be so beautiful if you configure it properly. So this Torus node shape is not only something that you find in 3ds Max, but it is actually a mathematical object. And they point in this object that there is a P and Q torus node is a node on the surface of a torus that goes around P times in a meridian direction and Q times in a longitude direction. Again, this is a definition that I took from the internet, from Wikipedia, just to make sure that I'm aligned with the official resources. But if I would try to explain it in a very simple way, if you take a donut, and there is a P and Q numbers, right? There is two numbers. So P is the amount of times that you have to go in meridian direction, which is basically up and down around this donut. And then Q is the amount of numbers that you have to go around the torus in a longitude direction, which is basically results in a shape that you see from the right side. And what you see here has parameters 3 and 8. It means that it wraps around the donut 3 times in the meridian direction, and then it has 8 sides, and that's what you can see on the screen. So it makes 8 wraps in the longitude direction, which is resulting in 8 sides in the final shape. So when I saw this shape, I thought that's what I was looking for. That's it, because it has symmetry. It's not necessarily like full symmetry, but it has because some configurations can make it a little bit asymmetric, but it still have very interesting shape. It looks like flower, like star. You can bring a lot of configurations. This is basically what I was looking for, and it's also is a mathematical object, so it's not just some random lines that are being drawn on a canvas. So I tried using this for my artworks, and I was only taking a torus node with different parameters. I was configuring it in a 3ds Max, and I was using brush strokes as a base for it. So you can see some of my first artworks. And each of them, when I will create it, because of the shape and the colors that I would use, I would have a name for each of them right away. So there is a first one called Salamander, and then there is a Stardust, and then there is Golem. And then the fourth one is Moss, because just it's green, it reminds me of moss. And then one more, it actually has a white background, so it's just a little bit bad quality of a picture, but this was a present from my mom. And I guess so far it's one of my favorites because it's really has a very nice, vibrant, beautiful colors. And this one as well is called Glyph, and the previous one is Flux. For some reason, when I create those artworks, I always have a name for them because I have an association. So I really liked how I felt about it. And I also saw that for other people, for different people, it will probably bring different associations. So I would just try experimenting, but I was also kind of done with 3D modeling tools because I remembered that I saw similar shapes, but in 2D view that were described with formulas. So one of the screens that I showed you before was also like a flower or star shapes with formulas underneath. This is a 2D representation of parametric equation. So if there is a formula for that, then there was for sure formula for something like this for torus node in 3D space. So I thought I would give it a try, and I would just build a tool to generate shapes from me. So I would have no need to sit in front of 3ds Max and do all those manual configurations and all those manual changes. So before getting into more details about actually how the tool is built, I'm just going to say a couple of words about different types of art, just to make sure that everyone understands it. So there is algorithmic art, which is basically defined by algorithms, and it's always the same outcome. Doesn't matter how many times you rerun the code or rerun the algorithm. The outcome only depends on the complexity of the algorithm. And then there is different thing that's called parametric art. And you saw all those Torus nodes. They are described with parametric equations. And what you see on the screen, this is parametric equations for 3D representation of Torus node. So the difference between parametric art and algorithmic art is that parametric art depends not only on algorithm itself, but also on the parameters. And in this case, parametric art is described by multiple equations, and it depends on time. So that's why we have X, Y, and Z, and all of those shapes at some point of the process, they are represented in a 3D space, and I adjust them and I make sure that everything is smooth and nice. But this is basically this is the baseline for the tool that I created afterwards. And then there is generative art. It has it has something to do with generative art, generative AI, but it's not the same thing. So generative art is very similar to algorithmic and parametric art. The only difference is, in very simple words, that I would say that it has a certain randomness. So you have a system that is semi-automated, and you bring some randomness. So you bring some unexpected result every time you rerun the script or you rerun the algorithm or your code. It will give you different result. This is what called generative art. So I knew that there is algorithms that I can use. There is equations, and I knew that the shape that I want to build is going to be parametric shape. But I also wanted to make it a little bit more complicated, more complex, because it would be way too boring of just using a formula, making it always the same, and just changing parameters. I wanted to make it more like independent, let's say. So I didn't want the result to depend on my decisions. So I wanted a tool to surprise me every time with the result that I see, with the outcome. So I thought I would go for generative art. I would try to make it every time different, and it will depend somehow on the outer parameters, on the input from the user, which is in this case is me, but also not that much. So there will be a lot of space for interpretation and changes. So this is a very basic idea. There is a user input, which can be basically anything. There was a point in time when I saw that I could collect environmental data from like temperature, humidity, from like IoT devices, and maybe like create a little visualization for it, and then you can put it on the screen as like, like a daily art thing. You can have a personalized art based on your environmental data. I thought that that could be a use case, but also I thought that sometimes I don't want to think too much and I just want to put something, I don't know, I would like to see a shape that has a nice sunny weather, or I would like to see a shape that reminds me of flower or nice vibrant colors. You get the idea. So from this user input, I wanted to generate our description. There is a prompt, of course, that takes this input and it tries to generate something more like artistic. So it transformed it in a way. It is this step is not actually necessary, but I thought that it would be a very nice addition to transform this user input in something artistic, like the description of the final shape. And then when I have my artwork done, I can also add a description, and it would be like a complete artwork altogether. But I still like to have a description because I think it's also just interesting to read like the how it looks based on the data, based on the input that I give. So I generate the description, then I generate Torus node configuration based on this description. So I take it, and there is a prompt that I will show you later on. I generate a Torus node configuration, which is supposed to have a very strict format, very strict schema. Then I take this config and then I feed it to a visualize component. Well, basically, I just visualizing those parameters with P5GS. So that's like a very basic part. And now let's go get a little bit more into details, how it actually works, what kind of requests am I sending. So there's me as a user, there is a UI somewhere in the browser, and I'm sending something. So there's a text input, you can type whatever you want. Then there is my API somewhere, actually on my machine. So but there is a Generative Chaos API. I send a request to my gallery API to generate a Torus node configuration. Then I also have AI application with two LLMs deployed. So I have Text3 Large and GPT-4 Omni, one for generating embeddings, and the second one for generating descriptions and Torus node configurations. So I take my user input, I generate embeddings, and at this point, I don't do much with this. I will just save it in a database. So I generated, you will understand why just in a second. So I get those embeddings, and then I have a prompt. I didn't use embeddings for the prompt. I just take the user input, I put it in a prompt, like combine it with a prompt, and then I send it to GPT-4 Omni model to generate a design. So generate an art description and Torus node configuration. I call it a design because I think it's a one thing altogether. So after I got both of it, embeddings and then full design, which is configuration and description, and then I save those embeddings to Azure Cosmos DB. And I think that Azure Cosmos DB is an amazing platform, not only because this is my MVP category, but also because it brings data to a completely different level. With Azure Cosmos DB, you can store embeddings next to your data, which means that you don't need to use any other data store. You can have everything in one place, which is quite comfortable because afterwards, what I'm doing something called similarity search. So there is a couple of use cases for my tool. What I would want to see similar artworks or similar configs or similar designs for my user input. For now, I just wanted to see similar things so I can choose one. I can choose the one that I like the most. But for the future, I was planning to implement something like that I would get a similar designs, and then I would send all of them or like an aggregation of those designs to LLM and say, generate me something different, completely different, based on the knowledge that you have from previous results. So I thought it's a very cool feature that has a lot of potential. So that's why I'm using also Azure Cosmos DB for this. But this diagram doesn't really have all the components because I kept adding more and more features. So it is missing a blob storage because I'm also saving files in there, but you will see everything in the code. So let's get to that, I guess. Let's see how it looks. So let's go here first. I will show you first some code. I will explain you how it works. And I will explain you how it works. I will show you the logic that I have. I will show you front end, and then I will show you the UI. If you prefer the other way around, just tell me. I'm fine with anything. And also, by the way, please don't judge my code quality, especially frontend, because I keep changing things over and over again. And I think this is around the time that I need to start refactoring my code. But anyway, this is my Generative Chaos API. It has one controller. I didn't want to make it too complex. And here we go. So I will just go through different endpoints so we just get an idea of how it looks like. The first one is the most important, is generate design. It's based on user input, and then it sends, well, it uses gallery service, generate design. Very straightforward. Then there is a update configuration. This is needed for a case when I found a shape that I like, but I want to adjust it a little bit. So I go to a page, I make some changes, and then I hit the save button, and then it will come here and update my configuration. And it will also change the preview picture. So there is also an endpoint for this to upload preview based on design ID, and then there's an image. There is also an endpoint to get all the previews, which is basically which is for basically for gallery view. I wanted to see all pictures that I have, and I didn't want to use a visualization component for this. Get designs page. This is for getting designs items. So because I need ID, user input, description, and a Torus node configuration. And then I also need the previews, and this is 2 different endpoints. And then there is a search similar designs endpoint. So very simple, I guess. There is 5, 6 different endpoints. So how does it work? The first thing that we do, we go on a page and we type something in, we send a request. There is generate design endpoint. We come here, we end up, actually, let's check this. There's a gallery service, and we see that there is 5 different methods in here. Generate design, search similar designs, get design page, update design configuration. So update preview and configuration. So that's what gallery service does. If you go to implementation, this is a constructor. So we see there's just very typical things. There's Cosmos DB service, and there is also semantic kernel service. We get some data. We get some values from configurations from options, and this is for similarity search. So I'm getting either similarities from my configurations or the default one, and the same goes with the max amount of results. Then we have this generate design async method, which does a couple of things. First one, it generates embeddings. And as I said before, we don't do anything with embeddings. We just save them for later. So I generate them, and then I go to semantic kernel service, and then I generate design configuration. And I will get into an actual implementation just in a second. But this is basically what it does. Embeddings, description, config. We serialize everything. We create a design object. We insert it in Cosmos DB, and then we return a design DTO. Very straightforward, I guess. And let's have a look at how we actually do all this stuff. So get embeddings is very straightforward. We just get a require service, which is a text embedding generation service. And that's all. We basically just generate embeddings async, and then we send it back. So it's an array of numbers, and we need it for later to be able to perform similarity search. So not much to see here. And if you go here, this is a little bit different story. So generate design configuration consists of 2 parts. First one is generation of description. And I do it in a way that I say, I call create function from prompt method, and then I feed my prompt, and then I create the description for it. So I invoke it, then I get my description. I do the same thing for actual configuration. So same thing, create function from prompt, there's parameters, and then we get the result. I will show you prompts just in a second. What we do next is, if there could be like with LLMs, you cannot be sure that it's always 100% gonna give you a strict schema. Sometimes it will just put some random characters in the end, and then your serialization will fail. You have to be ready for this. Or at least I'm trying to be ready for this. So I'm having a default configuration because I don't want to see just like an empty screen. If something goes off, I'm getting a default Torus node that I know how it looks. So I know, okay, something went wrong, but at least I'm not disappointed with an empty screen. And then I just return those values. So prompt. First one is a simple one. You are an assistant that transforms creative art prompt into vivid, yada, yada, yada. I'll just put it like this. Hold for a second, you can read it by yourself. I put some limitations, some restrictions, some rules in this prompt. So I ask it to keep it for up to 1 to 3 sentences. So I also say, how do I want to see the output, that it should mention visual forms like structure and flow. And it should also have style influences and yada, yada. And that's how it is. I am thinking of changing this prompt because for the reason that the more I work with this tool, the more I get used to different parameters, and it's becoming more natural for me that there's like 20 different parameters. Like, this is the amount of parameters that I need to generate one Torus node. And I know almost all of them by heart. So right now, what I would want to do, I would want to put in my user input some values, like I would want to have p equal to 3, for example, and then q equal to 11. And I would want LLM to take into account those numbers. Right now, it's not going to do this. It will just completely ignore whatever I'm saying. But I would want, that's going to be the next step, like a next improvement. And then there is a prompt for design configuration. In this prompt, there is a, well, let's say first, there's a standard prompt, and then there is also a rule-based prompt. So I'm providing some additional rules, and there's multiple ways how you can call it, but one of the ways is a rule-based prompt. There is also a persona pattern in this prompt, which is act as a color theory expert and generate this and that. And also there is a template pattern, template prompt pattern. So I also want to be very strict with my output. So I provide a template or a schema, how I want to have my configuration. So as you can see, the second prompt is consists of multiple parts and a bit more complex, has some guardrails and rules, and like a lot of input. But this is what I expect as an output. Only this schema, because afterwards I need to serialize it. But anyway, so this is how it works. To generate the design configuration, I generate description, I generate an actual config, and then I return it back. And then we go here. Loop. Okay, so this is what's happening here. Generate design, then we come into a similarity search. Similarity search. At this step, I also do. So when I send a request from the UI, I send 2 requests simultaneously. One is to generate a config and a description, and second one is a similarity search, because I want to see similar items, but I don't want to wait for design to be generated. So I also send user input, and I have to regenerate embeddings for this case. Like, if any of you know the better way to do this, please let me know. But I have to generate those embeddings again for the same user input, because otherwise I would have to first save it to database and then query it somehow. I thought it's a bit overcomplicated. So I'm just simply doing it like double work, but I think in this case it's a good choice. So when I get those vectors, what I do, I perform a similarity search on Cosmos DB. And we go here. No, let's do this. So similarity search looks like this. It's just a very simple query. The only different or non-typical thing here is that we use a vector distance, which is based on our vectors property, which is this is our embeddings. And to get it work, of course, there's also some configurations that you have to do on Azure Cosmos DB side. So you have to create some policies, you have to create, you have to, well, basically do quite some configurations. If someone is interested in this to see it, I can show you Portal after the session, but I wouldn't want to spend too much time on it because it's already getting like quite tight. So, but anyway, this is there are some additional configurations that you have to do on Azure Cosmos DB to make sure that your vector search would work, and you will be able to save your embeddings, and they will actually mean something, not just array of numbers. But there's also documentation about it. If you do it correctly, then you should be able to do things like that. Based on vector distance, you can perform a similarity search or based on a similarity score. In my case, it's well, in my case, the score is like it's not going to be looking for exact items. If you would say, well, I'm looking for a flower and there's going to be something that reminds you of a flower, it will return me some results. So this is the query with parameters. And then we are getting the results. And yeah, so we're just getting the results back. This is the as much as I need in this case. So yeah, so similar items is a design DTO. It's the same object that I use in other places as well, which consists from preview URL, description, ID, Torus configuration, and user input. So there's also get designs page as just fetching data from Cosmos DB, basically updating design and updating design preview, and then updating design configuration itself. So this is very straightforward, nothing to see here. In Cosmos DB servers, just a good practice. I always try to remind about it. This is a good practice to generate partition key with partition key builder, adding a property. It's better partitioning, better performance, good practice as well. So you do that, and then you use it every time when you send a request to Cosmos DB. So I'm using here I have only one container to create items, to read items, replace, update it. So all the functions that you've seen before. Then there is a semantic kernel service that we've seen already. It gets embeddings. Yeah. So, and then there's file storage service. So file storage has only two methods: to upload files and get files. So very straightforward, not much logic here. And then I guess that's all. Actually, this is how my API looks. So there's of course some options and models and details, but I mean, you can also get my GitHub repository link, and then you can check all the details by yourself. What we're gonna check now, we're gonna check frontend, and I'm gonna try to keep it to the point. There is two things that I want to show. There are pages, which is basically I have three pages. It's a home page, design page, and gallery page. Home page consists from Torus node canvas, which is the main component. This is the main component that creates the whole visualization. So this is the brain of this tool. This is the Torus node canvas, and then there is a little input, little button, generate, and there is some navigation. So you will see it on UI in a couple of minutes. But basically, if you generated a design, you can also adjust it, or you can reset it, and you can regenerate a new one. Then there is gallery view, which is just a grid of pictures with user input. As simple as that, not much to see here. And then there is a design page. It's a little bit more interesting because it has same Torus canvas that we've seen before. And it also has all the inputs for all the properties that we generate, because then you can adjust them, and then you have some buttons here. So you can either set it, save it, or reset it, or download object file. Why, I will explain you just in a second. So 3 pages. Let's have a quick look on the Torus canvas itself. I spent on this component the biggest amount of time. I think my first iterations, I was just sitting with P5.js in a browser, and I was just doing all the math and calculations. I'm gonna be honest, I tried to reverse engineer 3ds Max. It was very easy to get a Torus node base shape, but 3ds Max has a lot of modifiers. So you can twist it, you can flatten it, you can like twist some rings around. You can do a lot of things. That's why you get such interesting shapes. I wanted to have the same. So that's why I have so many parameters in my config. I kept reverse engineering one by one after another. And this is my final result. It's quite some lines, but it's not that bad. So the main thing, what's happening here is this. So this is the entry point. You have those 2 methods and those 2 methods that are main logic. Everything is in there. So you create a canvas, you set up the view, the scale, everything is in there. Then you compute node path, which is basically depends on how detailed you want to have your shape. It just calculates based on the size of a torus node and the wave amplitude. So how big is the wave of well, how do I say it? Oh my God. It doesn't matter. So the wave is the how wide line goes up and down on this donut shape, on the torus node shape, on the torus shape. So it's the radius of torus node itself, and then the amplitude, and then the amount of rings, basically. So how detailed you want to have it. And the next method, compute rings with parallel transport. It's a weird name, I know, but it's the reason for it because it has all the math and calculations in there. You see how many parameters in this? Because every point that is being calculated here is the way how we calculate how the ring is gonna look like, taking into account all those parameters. So do we have to flatten it? Do we have to stretch it? Do we have to make it bigger, smaller? And then we build each ring like this. And then we can have like 400 of those rings in one torus node shape. You will see, if you don't understand what I'm talking about, now you will see in a browser how it looks and also how this Torus canvas works. You will understand the principle. So draw depth fill needed to make sure that I will not be able to see through the lines that are underneath a torus node. So I want to see only the top surface. I don't want to see a back one. So like what is behind it. So I'm filling it with color, and then I'm creating a wireframe on top of it, which is basically like, you can think of it that you create a wireframe 3D object, and then you put some color just like in the middle of it to make sure that you cover all like back points. I'm not sure if this makes sense, but anyway, that's how it works. So I fill it with color to hide other lines, and then I create a wireframe. So that's the main logic for the front end. I use white and React. I don't know why I made this choice, because I just wanted to try white because I never used it before, and it's fine. I mean, I think it was the easiest setup that I've ever made. So let's go to browser. And this is how it looks like. So I'm running it locally. There's my homepage. This is the default Torus node shape. It's just a configuration that I liked, and I just saved it as a default value. And then I can say it's raining now here, so create me a shape that oh, I don't know how to say it. I want to bring some sound in there. Create me a shape that will look like a sound. Let's do it very simple. I don't know why my imagination, my fantasy is not working when I'm giving this a session, so I couldn't be more creative than this. I'm sorry. If you have a better choice, better input, just let me know. But anyway, I hit generate button, and I still need to add like a little loader, so I will know that something is actually happening. But oh, okay, something went wrong. That happens. Probably I stopped my front end or something. Interesting. I tested it before I started the session, so it has to work. Let's try it again. Let's see what's the problem
because
here.
you're just asking it being like sun, but it's rainy outside. So
Yeah,
it's
it could be. Oh, you see, that's actually, but it never gets blanked out like this. So something went wrong with the properties and background color of config.
Let's fix it. Yeah, debugging session.
Yeah, did I? I think I was like removing some. No, it should work. Let's restart my backend. We're not gonna leave until I show it to you because it looks nice, and I will still want to show gallery. There's no reason for it to not work. So, background color.
Defined somehow.
Yeah, but that's config is undefined, but this is the default config.
Should be passed as a parameter, right? So
yeah,
navigate sign config, isn't it? I thought I
design config. Here you go. Background color. Let me do it. What did it say? That's no background.
I thought it's not a config. What it's saying.
As it is in the
so
structure.
Take a different config. Maybe.
Let's try all
Oh yeah. Pretty empty.
What?
Was the callee?
Hmm?
The callee, the parent method that calls this?
It's here, it's Torus
And I
canvas,
think there's
it's
also
in
no
home,
valid config.
config, new new design, Torus config, new design,
Pretty empty then.
Torus config. From the user store, and it's default config.
Is the config generated, or do you have it somewhere on?
It has a default config. Torus config.
That's
Let me try. It's crazy. Okay.
nice.
What is going on here?
Yeah, it's demo god. It does not like the weather.
Like I just ran it before. Yeah, but it's fine because it's not passing anyway. Yeah.
We can find out. Just take your time.
Yeah, let me show you the rest, and I'll see if it's actually still necessary. Because yeah, anyway, it's fine. It's always happens. Actually, no, it's not always happens, but that's a fine for demo. This is a gallery page. So there's the home page that doesn't work for some reason. Thank you for messing up my demo, but anyway, then there's gallery page. Gallery page has all items. All items that are generated on homepage, they land here. As you see, there is some items here already, and you can load more. So my goal was that I can just come here anytime, and I can pick the shape that I like. Well, I like this one, this one, this one. They are all nice. I can open it, and I will change this value because I still need to improve my performance, because otherwise my browser will hang up. So I can open it and I can play a little bit around. Well, not a little bit, but I can basically change whatever I want. I added this functionality because sometimes, let me give you an example. This one? Yeah, you see, sometimes there is like, when you make a torus node shape, the points, the starting point and the end point, they will not be properly connected. So why I did this, because I can then come here and I can play a little bit with those global twists. So if it has twists, then I can twist it even more and then make sure that it's aligned. Sometimes it works, sometimes it doesn't. Sometimes it depends on a different property that called lumps. So lump is basically this bulky part in the torus node. This is the height of it, and this is the amount of lumps that you have. So if you take them out completely, this is how it looks. And if you put, well, if I put back as many as I had, you see some parts are thinner, some parts are bigger, because lump has a height, and this transforms a shape. Electricity is basically a distortion. If I say it, see, it creates like this distorted shape. I don't really like that much this parameter, but I still thought it's nice to have it. P and Q, those are those numbers that I talked about before. You want to make sure that they have common divider, I guess. 1, because if you put this one to, let's say, 15, I'll just show you an example. You see how it looks? It's not pretty. It's weird, actually. So that's what happens when you choose the wrong numbers. Basically, all of those things, they have a big influence on the final shape. So eccentricity, this is how you flatten a tube in a certain way. So if I do it like this, you see it's getting thinner. And then if I change it, here you go. So you can make it more bulky, you can make it flatter, then you can reset it. You can save it. If you save it, it will update the preview and it will update the config itself. And then the next step, if I really like this sketch and I say, okay, I want to work with this, I would hit this button. This is also different format. I didn't find it useful so far, but there is this one as a object file. What I do, so this is the path details. So every line here is a path, and then you go like you wrap it around the torus. And for example, there is a path details 350. I can put it to 200, and you can see that there's less lines, like there's less rings basically. So that's what I was saying. This is what we are calculating in the torus node component. So we calculate how many of those rings we're gonna have, and then each ring is being calculated based on all of the rest of the properties. Because you see the one ring is smaller, and then it gets bigger and bigger and bigger, and then you have 200 rings, and that's how you build this shape. So when you download this object file, what it is actually something that you can open. I don't have 3D Max on this laptop, so I'm not gonna show it to you, unfortunately, but I don't know. Well, you can probably see. So there's like shape in there. The point is, it doesn't really matter how it looks. The point is that I take this object, I open it in 3D Max, I make sure that my camera perspective set correctly, and then I just export to the representation. Well, look, I do some more adjustments, and then I just get a 2D shape out of it. So I automated the process of manual configuration and manual adjustment of a shape, and I got to the point that I only need to open it and download it because, to be honest, I was very ambitious. I saw that if I can generate this, then I should be able to extract also a 2D view out of this picture. And it turned out to be much more complicated than I thought, because I'm using WebGL here. WebGL as for generation of 3D object, and it's not that easy to get a 2D vector representation of a 3D object like this. I think I'm lacking a little bit of math and understanding how all this stuff is being calculated to make it actually perfect in the end. This is still my goal for the future, but it's probably going to take much more time than I have now. So yeah, so this is basically how it works. I will check the home page, I guess, later on. Don't want to take more time from you to debug it, but we saw that there is input, and then we hit the button, and then we should get the generated shape. It looks the same. Then you can you can just generate more shapes. But then what I do afterwards, I always go to gallery, and then I just check all the shapes that I have and just play around with them. As you can see, there's quite some already. So I have I have more artworks to create. So what I want to say, have a look at this shape, this one, and have a look at this one probably, and there is another one, I don't remember which one, probably this one. So those are things that I generated. And if we go back to presentation, those are artworks that I created using those sketches that I generated. So you see this one, and this is the final result. So I had it, I downloaded the object file, I exported 2D vector representation of it. I created a G-code file, which is instruction for a plotter machine of how the pen should work, like should move. Of course, I also put a lot of manual work in there, because all those effects and like the brush strokes, colors that you see, it's done by me, at least something creative and artistic, and then it's been printed on top of it. It's still a lot of work, but I'm also very happy that I could reach a result like this. Yeah, so that's the tool that I created. Now I can create those beautiful artworks. Um, yeah, and actually keep talking about it at the conferences and give sessions like this. So thank you very much for this opportunity. And at this point, I would say thank you. There is my contacts. I guess there's still going to be a couple of minutes for some questions or comments. Yeah, but feel free to connect. And yeah, thank you
Sure.
very much. Yeah.
That was awesome. Awesome. So it was
Thank
really, really
you.
great to see what you did so far and then the art that you produced. I especially have a favorite. So that was the segment that you showed. That is from what I saw already. That is my favorite, my personal favorite. I really liked it.
In the last one, last here?
No. The second of all the pictures you showed. So the first try that you did and the second one. So the second one is what I personally really liked.
Okay. Like
Second
here?
one. Yeah. So the
This one?
so with the plotter. So the
Yeah,
picture of the
this
plotter,
one?
the number six, the second one. So I really liked it.
This one. This one.
No. The previous
Which
one.
one? This
The
one.
previous one, and then on the right hand side.
On the right. Yeah, okay. Yeah, it's a big one. I started
That's
doing
my
like,
favorite. I like that.
yeah, it's you put a UV light on it and it's glows in the dark. It's actually very cool. I would do more experiments like this. So actually I'm planning to do more stuff like that. But it's actually also a big one. And I really spend a lot of time like, learning
Can
how
imagine.
to, yeah, like getting those segments out of it. And then it was the second time that I ever hold the brush like this because it's a big one. It's like, like 20 centimeters brush. And you have to learn how to combine colors, not to make a mud on a canvas, but actually make it pretty. It was fun. I loved it. So
But it's worth it, right?
yeah,
So it looked
definitely.
crazy. So really incredible. Thank you. That was really, really cool to see all the insights, the mathematics behind and the combination, and all this brings art that is incredible. So I really like to see what you've done, and I see your passion in it, talking about it. It's great to have you here. That's awesome.
Yeah,
But I
thank you
leave
very
the
much.
space for others to also comment this, so it's not me, just talking.
Yeah.
But I have a few ideas.
Oh, someone couldn't find Instagram. Oh, I will drop my link in the chat just because in Instagram, actually, I post also a process of how I make this. Here we go. Here we go. There's my Instagram. And if you go there, it's not only just my pictures, but also mostly the either process or my artworks. You can follow there as well.
Yeah, everyone is invited to leave a comment or just switch on the microphone and then the video and just talk to Olena. I'm pretty sure that Olena, you're still a couple of minutes here, right? So you will have a
Yeah.
bit of time. That's
I was
great.
just reading the chat.
So I give it a little bit of space, then I turn off the recording. There's no question, no comment anymore, which would be really sad. Much
Backyard beer
mathematics.
sound.
But maybe it's the recording. So for all the people that are watching this video after we've done it live, so it's ending here. You're welcome to get in contact and touch with Olena so far with her contact details that she shared. Yeah, have a good day for all those that are monitoring.
Oh, hold
Last
on
words.
for a second.
Yeah.
Did you stop recording already? Let me
No,
just
no, it's
share
not stopped.
one
You
more
can you
time.
can
Yeah,
you
yeah,
can
because
fix your Insta. Yeah.
I changed my Instagram handle. That's the
Of
correct
course.
one. So I'm just gonna show it once again. So if people wants
Yeah.
to, yeah, now
So
it's done.
it's
Now
not the
you can
best
stop.
showdown.
Yeah. Anyway,
Oh yeah. So everything's okay to stop the recording? I'm just asking.
yeah.
Fine. So stopping the recording. On hold.